Welcome to the live session of Laser-Based Manufacturing NPTEL Online Certification course. Myself, Shri Krishna and Joshi. I'm working in Department of Mechanical Engineering, IIT Guwahati, as a professor. I welcome you all and I thank you all for enrolling this course, Laser-Based Manufacturing, and shown your interest to learn the techniques, various aspects of using lasers in manufacturing. Well, I will go through the content which we have gone through till date, and then I will take up your questions one by one. Well, my friends, we have completed 4 weeks of this course. Halfway we have done, and the 5th week is going on. That is on the processes which are related to the surface treatment. Well, at the start of the course, we have seen the fundamentals or introduction of laser-based manufacturing. To start with application of lasers in manufacturing, we have seen what is the meaning of manufacturing, the definition of manufacturing. Of course, it is a transformation of raw materials into finished parts and products. Then we have learned various manufacturing processes being used, the conventional as well as the unconventional way of carrying out the manufacturing, and the prominent way of using thermal energy for getting the work done, maybe for forming or for machining. What are the various processes which are available that we have seen? And one of the process is laser-based manufacturing, and it has its own uniqueness. It has its own advantages. That's why it is quite popular in the industry. It is playing a major role in the manufacturing industry. Then we have seen the meaning of laser, which most of you know. Again, we have brushed up our fundamentals about the laser. Its basic characteristics such as incoherency, non-directionality, and different wavelengths, which are the problems associated or which are the characteristics of in general the light radiations, and that incoherency, non-directionality, and having the different wavelengths have been changed to coherency, directionality, and having same wavelength to get an intense beam of thermal energy in terms of the laser. That is a laser which is having coherency, directionality, consistency, and of same length, and waves are parallel to each other. So we have seen all the theory related to the lasers in manufacturing, various applications of lasers in manufacturing in detail that we have seen. Afterwards, we started the second lecture. Again, we went into the physics of the laser and the meaning of these characteristics such as monochromaticity, coherency, and collimation. It's a highly collimated beam that we have seen in detail. So these are all the things. The Bohr's atom theory we studied to understand the process of generation of lasers. Right, so I will not go into the details of this. All these details already you have gone through and you have studied them well. Then after studying the laser fundamentals, we went for the construction and types of lasers. So various types of lasers being used, such as gaseous lasers, solid lasers, and you can say the diode lasers. So all these types of lasers, how they are working, and the concept of population inversion, how it is useful in generation of the lasers that we have seen. Various terms associated with this and how to get the population inversion during this process. The construction and basic components of laser system that we have seen. Meaning of cavity design and getting the uniform laser beam. Then various types of industrial lasers, their classification based upon labels, active medium, output, whether it is a continuous or pulse mode, wavelength, and the industrial lasers based upon the safety or hazards. In detail, we also looked at the advantages of lasers. There are limitations because laser technology also has a limitation of low efficiency, and how to solve these problems. We have to systematically understand the process of laser application in manufacturing so that we can increase the efficiency. So that is one of the objective of this particular course, to sensitize, to disseminate the knowledge related to lasers being used in the manufacturing, and to make them more applicable, more employable in the manufacturing sector through you. So that's one of the prominent objectives of this course. Well, in the week 2, we started with the laser-based material removal, the principle of operation, types of various lasers that we have seen. We have seen the concept of curve. So it is a material removal by using the lasers. So curve is the width of the cut that we are getting. Of course, this needs to be considered when you carry out the actual operation. There are two modes of laser cutting, the pyrolytic process and photolytic process that we have seen in detail. And yeah, this is the photolytic process, its construction, and later the arrangement of laser cutting such as fuse cutting, flame cutting, and remote cutting we have seen in detail. So here also we have a detail in discuss how it is useful to understand or to employ the curve during the CNC based application. Then some of the terms related to the laser based material removal, that is the striations, how to control them, and what is the meaning of striations that we have seen. Fine. Then fusion cutting, the flame cutting, and remote cutting, the concepts that we have seen. OK. Then types of material removal, process and performance parameters. These we have seen in the second lecture of lecture 2. So various types of lasers being used, mostly Nd:YAG or CO2 based high power lasers are used in laser based material removal. Their construction, working in detail that we have seen. Then various process parameters which are affecting the product quality, that is the geometrical accuracy, roughness, HAZ, that is heat affected zone, and recast layer. So what are the various properties, parameters are there, and how can we classify them into 4 different groups, such as beam properties, transport properties, gas properties, and gas is the inert gas properties, and the material properties that we have seen. Their effect on the material removal that we have seen in the subsequent sessions. Fine. So in the third lecture, we have seen in a case study the actual part being cut during the laser operation by using a 2.5 kilowatt CO2 machine for cutting a circular shape work part of 30 mm diameter on 2 mm mild steel plate that we have seen. Then we started the third week with the concept, or with the application of welding for with the application of lasers for welding operations. So we have seen what is the meaning of welding. It is a joining operation, permanent joining operation. Various terminologies associated with the welding, various types, welding classification, then sources of energy, and the laser welding. Then we started applying the lasers for joining two similar or dissimilar materials. So joining two dissimilar materials is the biggest advantage in laser welding. It's the biggest application, or the you can say the gift given by laser welding to us. Right, mechanisms of laser welding. There are two modes. That is a keyhole-based laser welding and the conduction mode. We have seen both of them in details. Then various types, and then we have seen the process parameters used in laser welding. What various various defects also that we have seen. So here you can see on your screen various process parameters which are affecting the laser welding. Various defects and how these process parameters are affecting on these defects that we have seen. Again, in the lecture 4 of laser welding, we have gone through one case study. A video was discussed or video was presented to you and a discussion was carried out to understand how the two plates are getting joined permanently by using the laser-based machine, laser-based operation. So this is the video that you have seen already. Fine. And in the previous class or previous week, you have seen the laser-based forming operations as well. How lasers are useful to deform plastically the material without contacting it. We have seen the TGM, PM, and UM, temperature gradient mechanism, buckling mechanism, and the upsetting mechanism, and various theoretical aspects related to the laser forming. In addition to that, one small video was also shown to you. So with this, we are learning how lasers can be used to apply, or how the lasers can be helpful for us in the manufacturing operations. Week 5 onward, you will be studying the heat treatment, alloying, cladding, and some of the applications in the automation, and some advanced level application of lasers in manufacturing. Fine, so let me look at right. Fine, now let me take up the questions. Yeah, there are many learners are there online. Good afternoon. Yeah, thank you all. Right, thank you very much. Fine. Yeah, you can ask the doubts. You can write the doubts in the chat box of YouTube so that I will answer them. Yes, Rajesh Guria is there. Rajesh.
Yes, sir. Very good afternoon.
Good afternoon.
Yeah, I'm audible, sir.
Yeah, you're audible.
Yeah. First of all, how are you, sir?
I'm fine. Yeah.
Yeah. Sir, actually, I have a question. In the previous week, where is a metal forming? I just learned a TGM method. Right? You said that there is a defocus laser beam, and for that case, the heat expansion is there on the metal surface, and for that case, the deformation is then on plastic zone. Right? So my question is that actually I'm a PhD scholar of Jadavpur University, and
Okay.
my question is that can we do what type of welding by this TGM method process?
TGM, the concept for forming and welding, the concepts are entirely different, my friend. Here, how can you have the TGM to be used in butt welding process?
Sir, actually,
Because
it's just my opinion. It's my opinion on justification. You can
okay.
what you say. Sir, actually, when the laser beam, defocus laser beam interact with the metal surface, that time some amount of heat expansion through the parabolic curve, it is expand through the metal, right? So if we focus that defocus beam on the metal surface, just offsetting the distance from the butt joining. I mean, there is a metal and plastic zone, plastic interference, right? And we are defocusing the laser beam, just offsetting 0.01 mm or 0.02 mm from the interference zone. So when we are defocusing the laser beam on the metal, that time due to the TGM process, due to the heat expansion process, some amount of plastic can be melted.
Fine, let me stop you. TGM is entirely different. And you're talking fine with respect to the melting. In TGM, or in forming, you might have noticed during my lectures as well. Forming and welding, the fundamental difference is the working temperature. So here we are not crossing over the melt point temperature in any case. Okay.
Yes, sir. Yes,
In welding, we want to have the temperature more than the melt point temperature. Otherwise, you will not get you can say the melting and solidification and the mixing of the two materials. Fine, yes, that's one point. So when we apply, when we want to have the melting, then we have to apply more power. Yes. More power and high power density that we require. Power and high power density, then your power should be high, first point. Your speed should be low, so that more energy can be put in. So there certainly it's not possible to get the gradient. And why gradient is essential? And if even though you want to use some kind of similar concept of TGM, but that will not be certainly the TGM. You can call it something different. But if you try to get the TGM, probably to my knowledge, you may not get the exact the butt welding there. You may get the partial welding. The butt welding, you should have the complete weld of or complete fusion of two parts from top to bottom. Otherwise, your weld would not be of good quality.
Oh, sir. Okay. Thank you, sir. But sir, one more question is that can we do the butt welding within the metal and plastic? I mean, is there any concept do metal and plastic butt welding?
Yeah, I have seen. I have seen one.
Oh, sorry, sir. Sir. Continue.
Sorry. Yeah, ferrous and plastic. Yeah, there are certain work was carried out. They tried to join ferrous material with polymeric material. Yes. Yeah, it is possible. It is possible.
It is still
yeah, it is possible, but you have to be very careful when you want to join because of the melt point temperature. Yes, certainly, if suppose the aluminum, it's okay, but stainless steel and say polymer, so it is difficult. But people have done that. You have to have two different lasers they used, and with a controlled environment they did it. It's possible.
At the time of literature survey, I have seen that maximum or huge number of papers are done on the lap welding. It's a polymer to metal or metal to polymer.
Yes.
But welding, paper is very less.
Butt welding, there are the arrangement difficulties. Lap welding, you can ensure at least some sort of mixing and you can say, but somehow if you are able to tackle with this problem of arrangement of getting two molten material together, that would be of good work, basically, good PhD work.
Okay, sir. Thank you, sir.
Yeah, very good. All the best.
Thank you, sir.
Yeah, anybody else? I could see here online on Teams. There are few of my friends are there. Yeah. Rajiv. Fine. So on YouTube, I can see there are many people are there, and I request them to ask the questions, get the clarifications from me. Yeah, there is one question. How the heat affected zone is prevented in laser forming? To avoid the heat affected zone in laser forming, there are various ways. The first fundamental way to control the heat affected zone is to apply the controlled energy, controlled power, and to get the optimal levels of the process parameters. Second way to minimize the heat affected zone, that you can use some artificial to have the proper TGM, like temperature gradient mechanism. So to achieve that TGM, you can have some sort of extra cooling from the bottom side, or you can use some artificial ways of controlling the heat dissipation during this TGM operation. So in this way, you can certainly minimize the heat affected zone. So in our hand, the prominent thing is to uh, carry out the parametric analysis, or even you can carry out some numerical analysis as well. Get the temperatures predicted, and then control, and then apply that control parameters. Yeah, one question is from Dhanya Rohit. He's asking me about the CNC, that is the computer numerical controlled. Yeah, of course, there would be one lecture I'm planning to have on numerical control, computer numerical control, CNC. But let us see how in what depth we can go for the CNC operations. Otherwise, there is another course going on of mine, that is automation in manufacturing. It's already lectures are there. The last few lectures of automation in manufacturing are dedicated to the CNC and CNC based programming, CNC based control. Of course, in this course as well, I will be having one more lecture. So wait for a week or two to get that lectures for you. Yeah, at the point of application of laser, whether there is any microstructure change in forming. Yes, there is a change in microstructure because we are heating it up and then there is a rapid cooling of the top fibers. Although we are controlling the parameters to avoid going it to below above the melt point temperature, but in certain cases it is beyond our control. The melting will occur. During that video also you could you might have seen that some sort of arcing was there. That was the burning of the oxide layers or the grease over the work part material. So there is generation of plasma due to the environment. There is a generation of plasma, and that plasma may lead to melting as well. Some sort of melting will also occur. And when the material is getting melted, so there is a change in microstructure. Even though we'll try to control the melting, the temperatures are more than the recrystallization temperature. So there is a change in microstructure. It's a good area of working for those who are working in MS or PhDs, the microstructural studies of laser forming processes. CNC more difficult to understand the programming system. Yeah, okay. Fine, I will try to give the fundamentals of CNC in one of my lectures, and you'll definitely enjoy. It would be very easy. CNC is not very difficult, my friends. It's very interesting and useful. And uh, let us see how much depth I can go for the CNC based programming of lasers. Okay. Yes, certainly, Vimla Shri. I will conduct more lectures on CNC. Automation, there is 1 week, and in that automation week, we will have more lectures on the CNC technology. So you will learn more about the CNC programming. Yeah, whether lasers can be replaced with electron for forming. Yeah, electron electron beam based forming can be done, but for nano level thin materials. Electron beam, they do have the depth of penetration very low. So for micro or even for micro or the meso level components, the electron beam based forming will not be of good choice. But if suppose somebody wants to work in nano thin sheets or foils, so their electron beam based forming can be done. But I've never came across with such kind of research work on electron based deformation. Yeah, good evening, Sindhuja. Yeah, there are many. Vidya is there, then SK, Vimla Shri, yeah, Mani, Nagapandi, right? Mallar is there, Algar, Madhu. You find Sharmila is there. Okay. Nijita, Deepa, Mahendra Prabhu, Mahesh, yeah. Yeah, SK, you're from IIT Palakkad. Yeah, nice. So thank you very much, SK. You're a PhD student, I hope, or an MTech student. MTech, yeah, very good. I hope you're watching or you are, listening to the content carefully, and the content are developed so that it can be used by the BTech students, MTech students, of course, PhD students, uh, to pursue some work in the area of laser-based manufacturing. So more interesting stuff would be coming in coming lectures on advanced application of lasers in manufacturing. You will enjoy this content certainly. Yes, striations are always there. Striations are there in keyhole. There is always some layers are found deeply, and these are the striations. These are basically when the lasers or the laser beam goes inside, it melts, and the assist gas will try to eject it out the molten metal. But due to the pressure or due to the velocity of that inert gases, the molten metal will try to come out. But during the process of coming it out, some portion is getting melted on that surface itself. And due to that, we are not getting a good quality surface finish in the keyhole based laser drilling. No, the handling of reflective surfaces is not with respect to the laser intensity. It is a function of you can say the wavelength of the laser. So you have to go for low wavelength of laser to process the reflective materials, or you can increase the absorptivity by applying a layer of grease, or you can apply a layer which will increase the absorptivity of the laser beam. So you can apply grease or lime, or you can even apply graphite or cement over that surface. Oh, thank you. Thank you, Rajesh, for appreciating. Thank you very much. And I'm happy that this course is finding useful to the learners or the students. Thank you. Fine. If there are no more questions, can we wind up? Thank you, Algar, for appreciation. Thank you. Yeah, there is one question. In stretching of thin metals, can laser forming be applied? Of course, yeah, that one lecture I would be coming. Laser assisted forming. So lasers can be used to reduce the flaw stresses, can use to increase the formability of the metal sheets. And we will be seeing one such case study in coming lectures of advanced topics of lasers. Only thing you have to be particular about the application of power. There you have to have low power laser heating. It's a laser heating, the preheating of the worksheets, and then you apply the mechanical energy. Yes, very good. And thank you. And then keep watching my videos. Yeah, conduct more session like this, please. Yeah, sure. I will come online and interact with you all. You can join me on the Teams so that we can interact or we can answer more questions live. Next time you come on, the link is there with you. Even you can come and join on the forum. So there is a forum, a Gmail based forum group is there. My TAs are there. They are always there. They are always be with you to solve your queries and the questions. I think you have enrolled Escape for this course and there is a forum, online forum. And through the forum, you can connect with us. You can ask questions and we have a system to answer the questions. There is a group that has been there and through that group, you can interact or you can discuss. In Teams, there is a link which is given to you all. So one of our enrollers was there, Rajesh Guria, who was there. I interacted with him live right now. The first question was from him only. Sure, Manthan, I will certainly come online and we'll have more interactions like this. Thank you. Yeah, Ajay had joined. Yeah, Ajay Kettler. At the end of every session, there is a feedback form is also there. You fill up the feedback form, give your questions there. That also be helpful for us to answer them and to improve upon. Sure. My email ID is snj@iitg.ac.in. You just visit the Department of Mechanical Energy, Department of Mechanical Engineering, IIT Guwahati website, and in the faculty profile, myself and my all details are there. My email ID is snj@iitg.ac.in. Fine. If there are no more questions, let us stop today's session here, and we will again meet as per the schedule given by NPTEL. Till then, keep on watching the videos and enjoy the course. Thank you. NPTEL
Thank you,
team?
sir.
Yeah, right. Is that all right, NPTEL team?